some notes, and then you guys will be dismissed, and these guys are going to do the penny lab like you guys did yesterday, the penny activity. And so I want to pick up where we left off, and I will do jokes here in a second. But just, again, a reminder is that, and I mentioned this yesterday, I'm going to send out an email here just to everybody, I want you guys to get the AP Chemistry Prep Princeton Review, the one that's four full-length test. I'll just leave it up here if you want to get it. This is going to be, again, and I mentioned this yesterday, this is going to be a thing that's going to help us review, help us get ready for the AP test, but it will also, I think, help your grade out, because I'm going to give you this big assignment. And I'd like you to have this by spring break. I think we have 3 weeks till spring break, I think. Is that right, Tyler? So in 3 weeks, get this, and I'll give you this assignment. And again, our class is not the kind where I tie your shoes or I, wipe your nose. I'm going to give you a big assignment right before spring break, and I'm going to tell you this is going to be due somewhere near the end of April, and it'll really be up to you to do it. I would recommend, especially over spring break, is to really start working on it. And there's a couple, they do everything in, I think they call them topics or units. And let's see, let me just get my verbiage right. The AP does. But there's going to be especially one that they just call them units. And Unit 8, we are really going to be kind of just crash learning in the end. But I'll talk about all this. But this is something you guys should order. And again, I'll just leave it up here. And if you want to get a picture of that, you guys should do that. Okay, so back to the notes. And I haven't forgotten jokes. I got jokes today. But I want to get back into the notes. And so that is the plan. So we're going to do 15, 20 minutes in the notes. And then we are going to, in here, we're going to do this penny lab activity thing. So, okay, so here we go. Why am I not getting there? We go. Click everything right. Okay, I actually want to go back a few pages. Kind of didn't get as far as I wanted the other day. Okay. At home, for those that are listening, can you see this?
Yeah.
You can. Okay, good. Okay, so let me go back over this. I didn't quite complete this, but in the notes the other day, and there's a couple things I didn't get to that I wanted to. So again, we're going to do 15, 20 minutes of notes, and then we're going to stop. But we went over, so we're talking about what does order mean? So when we determine the order, what does the order mean? And I think if I remember right, we talked about zero order, we talked about first, we talked about second, but I don't think we got to third. Do I remember right?
We were just starting third.
We're just starting third, okay. And remember we had the units on K, which is the rate constant, okay? And we were talking about that as well. And so we had, this was molarity per second. This was 1 over seconds, which also means seconds to the -1. Those mean the same thing. This was 1 over molarity times seconds, which also means molarity to the -1, seconds to the -1. Okay, third order, which we did not get to. Third order, so we have something that is cubed. So here, the concentration of the reactants changes. It cubes the rate. And all makes sense if you think about it mathematically. So if something is third order, that means as the concentration, or as the concentration of the reactant changes, it cubes the rate. Now the units. Now let's again review this. So the units on this, and just how you can just do this without memorizing it. So if I have rate times K equals A cubed. And A, the units on concentration are always going to be molarity. So if I have rate, which is molarity per second, so I'm just showing you how you could always figure out the units on K. And then I've got K, and then I've got molarity cubed. So I'm looking at it just in terms of the units. So here I'm going to solve for K. So what happens here then is this cancels out. And so what I get is 1, for third order, 1 over molarity squared times seconds. Which would also be written out as molarity to the -2 seconds to the negative. So that's what the order means. That's what the order says.
So those are the units for K if the whole, like, I guess
if the whole reaction,
that order.
If the whole reaction is said to be third order, right? So and that's a good question that Carson's asking. So let's see, what I think he's saying is we have K times A squared times B to the first. Overall, it's third order, right? Yeah, that's right. Okay, now one other thing that I didn't talk about, but I wanted to go over, I think I talked about this a little bit, but this is something I always put on the test. But rate depends on two things. It kind of goes back to collision theory. And again, at home, when you guys are Google Meeting, you in class or you that are doing it right now, if there's something you can't see or can't hear or I'm going too fast, you just need to speak up. But rate, here's the rate law, the rate of the equation. So if I change A, that's what we were talking about, that's going to change rate. So if I double A, that's going to affect the rate. So one thing that's going to affect the rate is concentration. And again, this goes back to the collision theory. But another thing that's going to affect the rate is temperature. And we talked about that with the collision theory. We said, and we're going to talk later on because I want to talk about rate constant. But at the end of the chapter, we're going to come back and talk about the rate constant. But collision theory, again, if you remember that and how that works. Well, the rate constant, and I'm going to come back and talk about this, but the rate constant, the lowercase k, it depends on, so it could change, again on temperature, so again temperature, but also on a catalyst. Also on a catalyst. And this is something, I told you there's two major points in this chapter. And we are, by the time we're done today, I'm going to give you one last problem to try for Monday. And then we're going to be done with this differential rate law, and we're going to move into the integrated rate law, which we're going to work on next week. And those are the two main things in chapter 12, kinetics, how fast reactions go. But there is a kind of a third point, which we're going to get to at the end of the chapter, and it's going to be about a catalyst and these activation energy diagrams. So, okay, so that I wanted to go over. Okay, now I want to go over an AP-like problem. And of course, hopefully you guys now, if the ones we've done in class, hopefully you guys have practiced some in the, in the book, some of these differential rate law problems. But of course, once you kind of got down the basics and how we're doing these ratios and these, these whole number ratios, but of course, AP, they always throw little wrenches into things. And here's an example. Okay, so I want to work through this problem with you guys. And then I want to give you another problem that came from a previous AP year. And have you guys work on that for Monday. So again, you always, it almost sounds kind of strange, but you always have to be given data to do this. Okay, it's time for jokes. Here we go. Whoops. Okay, jokes. What do you get when you cross a rooster with a duck? A bird who will wake you up at the quack of dawn. Didn't like that. Anybody that's listening online, you probably didn't like that one. Why was Piglet looking in the toilet? He was looking for poo. Did you know that one, Troy? Okay, last one. This guy, could have been a lady, guy or gal, goes into a bar, only person in the bar. It's like the middle of the afternoon, other than the bartender. And the bartender is up there doing whatever bartenders do, getting ready for their day, their evening. And so this person goes over in the far corner of the bar, and they're working remotely, like so many people are these days. And they're working away on their laptop. We'll just say it's a guy, and he's working away. And all of a sudden, out of nowhere, Lori, comes his voice, and it says, "Great haircut." And the guy is looking around, and there's nobody else in the bar. And where did this voice come from? He goes, "Man, I must be working too hard. Something's going on there." So he goes back to work, and he's working away. And then here comes this voice, and it goes, "Man, those are great looking clothes today." And he's looking around again, and there's nobody there. He's like, "Jack, what is going on?" Whew, I got these sounds in my head. So then he gets back to work on his computer, and finally, this is it. Here comes this voice again. "Great shoes today." He looks around, there's nobody there. He's tired, he's wondering what's going on. So he goes up to the bartender, he goes, "Is there anybody else in the bar right now?" And the bartender looks around, "No, the only one that's here is you." And he goes, "Well, listen, I keep hearing these voices talking about how my hair looks good, and my clothes are nice, and my shoes look good today. What's the deal? Who's making these voices?" Huh. The bartender goes, "That's easy. That is the complimentary nuts." You know, the complimentary nuts during the complimenting. That's all I got. Okay. Back to chemistry.
Remember that one.
Back to chemistry. Okay. If you look at this one, a little bit different data. So again, let's do this on both what we've been doing. We're going to find the rate law. Here's the vocabulary, which means we're going to find the equation. And then we're going to find the rate constant. So rate here is equal to lowercase k, the rate constant, times the reactants. Okay, so this is the x, and then BR negative, or I'm sorry, BR2 to the y. So the trick here is to figure out the x and the y. Now this one's a little bit different because in all the ones that we've done up to this point, there's always been those whole number ratios. Now one thing, and you'll see it on the next problem too, sometimes when I have one like this, what I'm going to do is I'm going to do one that I can figure out for sure. Okay, and this one's a little bit different data, and this one is actually a little bit more manageable because I can see that I got constant here. BR2 in experiment 1 and 2 is constant, so I can use to find x. Remember, if I'm trying to find x, I want BR2 to be constant. So I'm going to do that. Let's do experiment 2 to 1. And remember, I always put the larger number on the top. So I'm going to do experiment 2 over experiment 1. And what I'm trying to do here is I'm trying to figure out x, the exponent on the CH3COCH3. So I'm going to do the rate. I have 7.6 times 10 to the negative 5. Again, I put the bigger number on top. And experiment 1, 5.7 times 10 to the negative 5. And then the experiments are 0.40 and 0.30 to the x. Now again, I've done this before, but I showed you that the k would just cancel out, the BR2 would cancel out, so I don't need to include that. Okay, see if you can figure out what, use your calculators. See if you can figure out what x is. Okay, and if I remember right, this comes out to be 1.33. So does this. So the value for x is what? It's 1. Okay, so I now know the exponent for that. Okay, so now let's go on to BR2. So now we're trying to figure out the exponent for BR2, the y. And so I want to do this again where the other reactant is constant. So this is going to be experiment. What experiments would you use then? I'd use 1 and 3. See if you can do it. See if you can figure out what the value for y is. Okay, so I'm going to do an experiment where, again, the CH3COCH3 is constant. And I want to put the bigger number on top. So I'm going to do experiment 1 versus experiment 3. So 5.7 times 10 to the negative fifth. 5.7 times 10 to the negative fifth equals 0, 5, 0, 0, 1, 0 to the y. What's the value for y? It is 0. Good Lord, it's 0 because this is 1 and this is 5. But remember, anything raised to the 0 is 1. Okay, so this is first order in terms of the CH3COCH3. It is 0 order in terms of BR2. Okay, so now let's find the rate constant. The rate constant. So I can choose any experiments, 1, 2, or 3. This is going to be 1, so it's not really a factor in that. Okay, see if you can solve for the value for K, including the units for it. What did you get?
1.5.
Did you have 1.5?
I got 1.9.
That's what I had. I had 1.9. Laura, again, it doesn't matter which experiment I choose. Let's see. I'll just do 3. Okay, so again, I could have chosen any of these. So I'm choosing experiment 3. Probably be smart just to always choose 1. It doesn't matter. But I don't chose 3. So molarity per second equals K, and then I know the value. It is 0.30, and that's molarity to the first. Okay, so then if I solve for K, Mark, I'm going to check this and see.
I did the wrong.
So was it 1.9?
Yeah.
Okay. So the value for K, 1.9 times 10 to the, what did you say, Rex? 10 to the negative 4? 10 to the negative 4. What are units?
1 over second.
1 over seconds. I think we're getting the hang of this. Good. Questions there? Okay, last thing here. Let me just go. This page, what I want to do, and just because we need to get into this activity we're going to do, I'd like you to either, whatever you want to do, write it down, take a picture of this, whatever. And what I'd like you to try, and this goes for those of you at home, I would like you guys to try this one. The same thing. I want you to write out the rate law. That means this equation, and solve for the rate constant. Okay, so again, I want you to solve for the rate law of the equation. So I want you to figure out, okay, so it's rate is equal to K times ClO2 to the X and F2 to the Y. And then figure out the value for K. Now, if you look at this one, again, a typical AP test problem. Okay, so here's where they throw curveballs at you. And those of you at home too, if you look at the ClO2 concentrations, those kind of make sense because they've got experiment 1 and 2 that are the same, but 3 is different. But if you look at F2, they're all different. They're all different. So when you have one like this, it's a little bit different in how you're going to do it. So a problem like this, what I would do is I would determine the one that is not consistent, the one that doesn't have the same numbers first. I would determine the Y first. So I would use experiment 1 and 2 to figure out the Y for F2. And then when you figure out the X, you're going to have to include, I've erased it now, but you're going to have to include the F2 in the ratio. Okay, so say that again. So here, where the F2 is not the same in any experiment, I would figure out the Y. I would figure out that using where the ClO2 is constant, experiment 1 and 2. And then when I find the X, I would have to use F2 in my ratio. Okay, go ahead and try that. That's what I want you guys to do for the weekend. Okay, so for those of you that are online and awake, I am done with you guys for today. And so what I'll do with you guys then is you guys are dismissed. Could you see those notes?
Yeah, we were able to see it the whole time.
Okay, thanks, Alan. You guys are dismissed unless you have a question. I need to get these guys doing the penny thing you guys did yesterday. So if you do have a question, you can hang in there. In a few minutes, I'll be back. But if not, you guys are dismissed, and I will see you in a Google Meet again on Monday. So have a good week.
Thank you.
Good weekend.
You bet.
Thank you.
Okay, now you guys. So now we're going to do this penny.